Hello, my dear students. Welcome to Unacademy. This is your BVREDDY sir. Now, we have a great announcement from Unacademy team. Have a look at now here. As you might be know, in GATE 2024, this Unacademy students have performed very greatly. That is 7 ranks of AIR1 from Unacademy only. And many more ranks are there. Now it's time for you can start your serious preparation with the Unacademy. We are working for you dedicatedly. And so you can have a look at now here. These are the great opportunities the student who want to start your preparations for GATE 2025 के लिए. So this is just 11,999 only. So you can learn the best team you can learn. For this you can use a code of BVREDDY. Use a code of BVREDDY to avail the great opportunities. Right. Now, so these are the for iconic के लिए. So here 17,000 plus for plus के लिए 11,999. Utilize this opportunity before it going to expire, that is 19th June. And so these are the new batches we are starting. You can see now here from 30th June onwards, another subject I am going to start the networks. I am going to start. So do follow these courses. You can have a look at now here. So these are the batch for IN के लिए and these are 2026 के लिए भी batches है. Now you can have a look at now here. So you can be an Unacademy educators. So you can plan your Unacademy if you want, willing for this Unacademy educators. You can, there is a chance to get these opportunities. Right. And these are the list of books you can able to get once you have taken the iconic subscription. Have a look at now. These are the list of books for EDC, networks, electromagnetics, analog, signals and systems, control system, communication, digital, engineering, maths and aptitude for ECE. And similarly for electrical के लिए भी books है, सारा books which is available. You can start your serious preparation with an academy. We are there for you to help you to get the great success. So chalo, let's start our discussion now here. The last class we have completed the 45 problems तक हमने complete किया ना. Let's see the remaining problems. And take the next one, 46. Which one of the following sets of gates are best suited for the parity checking and parity generation? For the parity checking and parity generation, we use XR and XNOR gate. Which gates will prefer? XR and XNOR gates are used for parity generation and parity checking. Output of a logic gate is 1 when all its inputs are at logic 0. The gate is then that gate which will be called as what, tell me? Now this output of this logic gate is 1 when all the inputs are logic 0. Means when all the inputs are logic 0, tell me now which gate the output is 1, you tell me. And this can be happen in case of a NAND gate happens. And what else you tell me now? NOR gate also will happens. Even both inputs are same, means we can say this as what we can say XNOR bhi hoga na, tell me. This can be happens for even for XNOR also. Now you can tell me now konsa option high here. So this is the two combinations with the NOR or XNOR gate. Next, a 3-input NAND gate is to be used as inverter. Then which are the following is the way? Now, so we want to use this as a 3-input NAND gate to be used as an inverter. For that purpose, what we can do here? So I can connect the two inputs which are not used connected to what? Tell me now VCC. अगर VCC को connect किया तो क्या होगा? Tell me now here. It will behave like a not only na. So this is the A. Now the other two inputs I don't want required will be given to logic 1. So then output क्या बनेगा? You tell me now. This is A bar. The output of the logic circuit shown in the figure is, yeah, tell me now here this is A plus A bar whole bar na. A plus A bar is equal to 1. 1 bar means what? Tell me now 0. So this input is 0. And here this is A B bar. And this is bubble is there means 1. 1 into this is what we can say. Tell me now A B bar. Here is what? Tell me now here A B bar whole bar. And again this is what? Tell me now here A B bar whole bar will get cancelled. So finally Y, what I'll get to tell me? That is A B bar plus A B bar, which is nothing but what? Tell me now here A B bar only. So what's the option? A. Next, the circuit shown in the figure is equivalent to, circuit shown in the figure is equivalent to what? You tell me now here. So you can see now here this is a level 1 and this is a level 2. So this is a 2 level NOR logic. Yes, as we know that 2 level, 2 level R and logic, 2 level R and logic, which is identically equal to 2 level NOR logic. So this 2 level NOR logic is equal to level R and logic. So what's the option? Tell me. Option A. Next, the logic circuit shown in the figure can be minimized to, what? Now tell me now here this is what? Tell me now X bar and this is X plus Y whole bar. Now finally this output F, which will come it as what? Tell me now here X bar plus X plus Y bar ka whole bar. So that is which will come it as what? Tell me now here X into what? Tell me now here X plus Y, which will come it as what? Tell me now here X plus XY. So that could be given as what? Tell me X only. So this is, if I say this is X, output is also will come X only now. It is like a buffer. Next, in the figure shown, so the output is a ones complement of the input. So for that, what the condition? Tell me. So as we know, '𝐻𝐻𝐿' XOR gate behaves as an inverter when one of the input is 1. So this means this input must be, how much you can say now, this input must be 1. This is 1, this is 1. So this means y value must be 1 na. Agar y value 1 hai to it will behave like a 1's complement. The minimized logic circuit for the logic circuit is, tell me now here, minimized form. Here what will come here? X bar. Here this is what I can say now here. X, Y bar, Z. X, Y bar, Z whole bar. And this is Z bar. And this is output F. So that is F which is given as what I can say, tell me now here. X bar plus X, Y bar, Z whole bar plus what, tell me now here, Z bar. Now you can tell me now here which is equal to X bar plus Y plus Z bar plus Z bar, isn't it? So what I'll get to, tell me now here, X bar same now here, X bar plus Y plus what you tell me now here, Z bar. So this which we can modify this thing as X, Y bar, Z whole bar. Okay, X, Y bar, Z whole bar. So कौन सा option tell me now here? Option D, B. Next, the circuit shown in the figure realizes the function. Now tell me the output of this function. Here will come it as what, tell me now, AB bar. Here this is AB bar into C whole bar. And this is DE bar. This is output, if I say this output F, it should be given as what we can say, tell me now here, AB bar into C whole bar into what, tell me now here, DE bar whole bar. So it should be given as what will get, tell me now, AB bar into C plus what, tell me now here, DE. So this could be given as what, tell me, A bar plus B bar into C plus DE. So you can check the option now here. Option A. The output of the logic circuit shown in the figure is. Now, so here what will come here? A plus B bar. Here B plus C. Then here it is A plus B bar into B plus C. And this is what? B na? Now tell me the output Y. This is B only na? Yes, B. So tell me the Y which could be given as A plus B bar into B plus C into B. So tell me now if you simplify it now here. This is A plus B bar into this is B plus BC. Then which will come it as what, tell me now here. This will come it as B common. 1 plus C is equal to 1 only na. So finally it will come it as what, tell me now here, AB. So the answer is C. Now when two logic gates with open collector outputs are tied together, open collector output are tied together as shown in figure, the output obtained is hmm, open collector output. So that here there is a connected. So wherever it is connected at this location, we'll treat it as what tell me now here. So AND gate is there. That location will behave like what tell me now here AND gate. Now you tell me now here what I'll get. This is A plus B bar. This is C plus D bar. So then Y, which could be given as what? Tell me now here. A plus B bar into what? Tell me now here. C plus D bar. So you can see this option now here. Console option here. This it should be given as what we can say. Tell me now. A bar, B bar, C bar into D bar. Isn't it the same thing which we can also write it as what? Let me know here. A plus B plus C plus D whole bar. So that means both B and D are same now. Next one. Now, so this is the given function is equivalent to what we can say. So this equation we have seen this function so many times we have seen. So this is nothing but what element of here. So this is XR gate Barfi. हमारा Barfi है. So you can see now here this is AB bar. Here this is what element of here A into AB bar whole bar. That means what I can say this is A bar plus AB. So this is what we can say now here A bar plus B. Now here the similarly here what will come here B into AB bar whole bar. That is equal to similar to B bar plus A now tell me. So what is this output you tell me now here? F. It should be given as A bar plus B into what tell me now here? A plus B bar ka whole bar. Now tell me now this is nothing but what tell me now here? A bar B bar plus what tell me now here? AB ka whole bar na. So this is nothing but A 𝐂𝐤𝐴 B whole bar. So that is nothing but what tell me now here? A 𝐂𝐤𝐴 B. Got it? Next. The circuit shown in the figure is equivalent to what? The circuit shown in the figure is equivalent to what you tell me. So you can see now here. It's a very simple thing here. The simply modified, you see this thing here. Here this bubble. This bubble I will remove. I will place a bubble here. This bubble I will place here. This bubble I will place here. So this is exactly option D. Check it. Isn't it? Next. The output of the circuit shown in the figure is A plus B. Now tell me now this is A plus B into C whole bar. Now this is DE. Here this is the NOT gate, so this is DE bar. So what I'll get this Y value, tell me. What I'll get this Y value, so this is A plus B into C whole bar into what, tell me now here, DE bar whole bar. So tell me now what I'll get here. This is A plus B into C plus what, tell me now here, DE. Check it all of you. Option is there. Yes. Option A. The output of the given circuit is, now they given this is X. So tell me now here X XR with X, which is equal to what, tell me now, 0. Now this is 0 XR with X, which is equal to buffer X. So now this is X. Again X XR with X, which is equal to what, tell me now, 0. So output Y is equal to 0. Next. Which one of the following circuit is the minimized logic circuit for the circuit shown in the figure? Which one of the following is a minimized form? If I call this is output F, tell me the F here. So here directly A will come, this is C will come. What will come here? You can see now this is A bar and this is B. This is C bar whole bar. So here tell me now here F, which could be given as A plus A bar B C bar whole bar plus C. Then it should be given as A plus B bar plus C plus C. So it should become what, tell me now here, A plus B bar plus C. So then which could be given as what I can say here, A bar B C bar ka whole bar. Now tell me now कौन सा option? Option B now. Next. The circuit shown in the given figure realizes the function. Now you can tell me now this is A plus B bar. This is A plus B bar plus C whole bar. Then what I'll get, tell me now here, A plus B into C bar. Now this is D plus E bar, then that is D plus E, then finally F. So what will come here, tell me now here, A plus B into C bar plus D plus E whole bar. Yes. So simplify this thing here will come it as A plus B into C bar whole bar into what element of here? D plus E whole bar. So you can see this thing here. Now this is A plus B bar plus C into D bar into E bar. De Morgan's law. So कौन सा option check it now here? Option A. The logic operations of two combinational circuits in figure 1 and figure 2 are the logic operations of two combinational circuits in figure 1 and figure 2 are. So we need to identify whether there is any relation between these two figures or not. Okay? So tell me now here if I call this is output F1 and this is F2. Tell me the F1 here. So this is F1 which is given as X plus X Y bar whole bar. But this whole bar. Sign up. 1 second. This is not yet. No? So here it is what element of here? X plus Y bar whole bar. Right. Now this is X plus Y bar whole bar whole bar. Now so simplify this thing here. What will come here? X plus X bar into Y whole bar. Also this is F1. We can apply the mingle property, so it will become X plus Y ka whole bar. So that means F1 we got it as X bar into Y bar. This is about the F1. Now tell me the F2 here. F2 which is given as X Y bar whole bar. So that is F2 tell me now here will come it as X bar plus Y. Now you see, do you have any relation between these two F1 and F2? No. Complement? No. Yes, entirely different is a correct answer. These are no way related, right? These are completely different. Next, if the output of a logic gate is 1 when all its inputs are logic 0, the gate is all inputs 0, then output is 1. So I think अभी ने ये problem हमने किया ना अभी. So this is when both are 0, 0, this is 1. Which case can happen? So tell me now here. So the NAND can happen, okay. NOR also can happen, and as well as what else? So tell me now here. XNOR also can happen. So tell me the option now here. Option A. Next. How inversion is achieved using XOR gate? Yes. In case of XOR gate, one XOR with A, which will be given as what element of A bar na? If one of the input is 1, that is behave like an inverter. So, cons option tell me now here giving the input to lie and logic. One input is given to the normal input, other input is given to the logic high. Next, the circuit shown below is functionally equivalent to what? This is functionally equivalent to. So A bar. So this is A bar into B ka whole bar. So that is what we can say now here. A plus B bar. And this is A B bar whole bar. तो क्या बनेगा इधर? This is A bar plus B बनेगा. So you tell me now F is equal to what? Tell me now here. A plus B bar into what? Tell me now here. A bar plus B whole bar. ठीक है? So that means what will come here? So this is so it will become as A bar B bar plus what? Tell me now here. A B whole bar now. So this is what? Tell me now here. X nor whole bar. Finally it will become what? Tell me now here. XR banega. So option C. Next, consider the following circuit. What is the required input combinations to make the output X is equal to 1? To make this output is 1, the conditions are, this is the AND gate now. When the AND gate output is 1, you tell me? When the AND gate output is 1, when all the inputs must be 1. So that means this must be a 1. And this is which gate you tell me now here? XNOR. When the output of XNOR is 1, both inputs are same. So this must be also 1. So this is 1. This is what? Tell me now here? XNOR. When the output of XOR gate is 1, you tell me different inputs. So this is 1. So this must be 0 now. So means what I can say? A must be 0. B must be 1 and C must be 1. So, कौन सा option? Option D. Next. And the circuit shown below is to be used to implement the function. What values are to be selected for I and J? What should the values I need to select for I and J? Now tell me the output now here. What I'll get here? This is I plus A, this output, and this is A, and this is what? Tell me now here. A bar plus J. Now what about the Z? You tell me now here. This is A plus I into what? Tell me now here. A bar plus J. A plus I plus A bar plus J. If we apply the T2, what will come here? A into J plus A bar into I. So from this we can get the I and J values. Now by this comparison, so you can tell me now here IJ values. Now they given the Z value given as what? Tell me now here. A bar plus B. So by comparison of this term with this, I can say I must be 1 and J is equal to B. Yes or no? So option C. So what is this thing here? If we have A bar plus AB, so it should be nothing but what? Tell me. A bar plus B only na. इसलिए Mengel property. So tell me this output expression. So here A B bar and this is what? Tell me now. A bar B. So what is the F? You tell me here. So that is A B bar plus A bar B. So this is nothing but what? A XOR B only. Next, what is a Boolean expression? A XOR B is equivalent to. So here equal to A bar B plus A B bar, directly formula. Next, the output of the circuit shown in the figure is equivalent to. So here this is what, tell me now here? A XOR B bar. Okay, so this is nothing but what, tell me now here? A XOR B. We know this property. A XOR B bar. Yes, this is also equal to what, tell me now here? A XOR B. So you can see now this is XOR gate with the both inputs are equal. Output क्या बनेगा? Here 1 बनेगा ना? For equal inputs, output will becomes 1. The output X of the circuit is, yeah, here you can see now this is level 1, level 2, 2 level NAND and AND, which is equal to what, tell me now here? 2 level AND OR gate only now. So this is AB plus CD plus EF. So we know that 2 level and OR logic, 2 level and OR logic, which is identically equal to 2 level NAND logic. So directly we can say this thing. Next one. Consider the following gate network. Which one of the following gate is redundant? Which is not required? Yeah, tell me now here. This is W bar. Here W bar into X. Here this is X bar YZ. So finally F is equal to what, tell me? W bar plus W bar X plus X bar YZ. So that means which is given as W bar common 1 plus X plus what I can say X bar YZ. So that is given as what terminal here? W bar plus X bar YZ. So here this term, we can see now here, this term is not required, you can see. This is a redundant term, this term, that is belongs, you came from what terminal here? Gate number 3 se aaya. This is from gate number 3. The Boolean expression is realized using only two input gate. Which are these gates? We need to implement by using only two input gates only. Now see this thing expression what they given. So max terms are what they given? 0 and 5. So 0, how we can write? You tell me now. These are given max terms now here. So means so this is A plus B plus C and thereafter 5. So this is A bar plus B plus C bar, isn't it? Now So this thing which we can modify this thing as A plus C. Hmm. Mhm. A plus C plus B into what element of here? A bar plus C bar plus B. Now here, let us say this is 1, this whole thing is 2, this is 3, this whole thing is 4. So T1 we can try to apply now here. T1 is equal to what? Tell me. 1, 3, 2, 4. So you can see now what we'll get now here. T1 is equal to 1, 3, 2, 4. 1, 3 means B plus what tell me now here? A bar plus C bar into what tell me now? A plus C. This is nothing but B plus. So this is A bar C plus A C bar. So this is what I can say now here, B plus, which is A XOR C now. So we can implement by using XOR gate and OR gate से हो जाएगा. So option D, OR gate and XOR gate. Next, the Boolean expression for the output of the Boolean logic circuit is. Now tell me now here, this is A XOR B. And now, and this is C. So finally, what will come here? So this is C. So then Y, which could be given as what I'll get to tell me. So this is A XOR B into C. It should be given as what tell me now here A XOR B bar plus what tell me now here C bar. So tell me now what I'll get now XNOR gate. Now this is XNOR gate plus C bar. So what is XNOR gate to tell me now here? A bar B bar plus AB plus C bar. So option A na. Next, according to De Morgan's second theorem, a NAND gate is always complementary to AND gate. NAND gate is equal to complement. So NAND no. So here of course NAND gate is a complementary to AND gate, but that is not a De Morgan's theorem. De Morgan's theorem is what tell me now here? AB bar which is equal to A bar plus B bar. The NAND gate is equal to bubble to AND gate. Option C. Actually, the statement is correct, but that is not a De Morgan's theorem. Next one. X bar, Y bar equal to 1, then which one of the following is true? So here we need to verify the options. Verify karna padega by taking the different options. Let us say first option. So here, first of all, they given the condition as what? Tell me here. X bar y bar which is equal to 1. That means what I can say now here, x plus y whole bar which is equal to 1. That means x plus y is equal to 0. That means x must be 0 and y must be 0. Okay. Now tell me the option A, and this option A which is given us what? Tell me now, x bar y plus y bar x plus what? Tell me now, xz. Tell me now, if I substitute the x value 0, y value 0, what I will get here? X value 0, y value 0 will come 0. RHS will come. The RHS is a x y bar yz. OB 0 hai, so that means here the LHS and RHS both are equal. Sahi hai. Next check the option B. Option B. So that is x bar y bar LHS z bar plus x y z. If we substitute the values now here, 1 1, x is 1, y bar is 1, z. So that is z bar plus what tell me now? 0. So this is what I'll get now here, LHS z bar. Next, x y z bar plus x bar y bar z bar. So tell me now here. So this is 0 plus what? Tell me now here, z bar, which is equal to z bar. OB sahi na here. LHS is equal to RHS only. So this is also correct only. Now let's see the option C. So that is x bar y plus what? Tell me now here, y bar x. If I put this x value 0, so this is xy plus RHS x bar y bar. So this is 0 plus 1. These are not equal now, so this is not correct. Option D, x bar y x 0. So this is also not correct. So option A and B are correct. Next one. There are four Boolean variables they given as defined as like this. So they ask him to find what will be the h. So here, look at now here, this Boolean variables x3, x2, x1. Here x4, x3, x2. These two are different Boolean variables. Okay. In these cases, we cannot directly apply the product of min terms. So we need to analyze one by one. We should multiply and then we can do it. Just normal AND gates, it doesn't work here. So you can tell me now here F, which is given as what? Tell me min terms given x3, x2, x1. 3 means how we can write to? Tell me. That is x3 bar x2 x1 plus 4 x3 x2 bar x1 bar 5. So that is x3 x2 bar x1. Next, what of the G? Tell me. G x4 x3 x2. So that G, which could be given as 1, means what we can say? Tell me. x3 bar x2 bar, oh sorry, min terms different here. These are what will be now here, x4 bar x3 bar x2. Next 3 Minterm 6. Minterm 6 now here, so means what we can say x4, x3, x2 bar. Minterm 7, x4, x3 and x2. Now what they given now here? H. H is given us what, tell me, having the variables are what you tell me now here, combine all the variables x4, x3, x2, x1, which is equal to what they given now, f into g. Now we need to multiply these two, x4, x3, x2, x1. We need to multiply these two here. If I multiply these two, what I'll get, tell me now here, x4 bar, x3 bar, x2 and x1 plus. If we multiply here, we have x3 bar and x3 will become 0. x3 bar and x3 will become 0. Next, x3 here, x3 bar 0. Here this term non-zero. So this is x4, x3, x2 bar, x1 bar plus this x2 bar 0, this 0, this x4 non-zero now. So this is x4, x3, x2 bar, x1. So here tell me now, these are the minterms, we got it now here. So finally what are these, you tell me? So these are the minterms of what you tell me now here, 3, this is 12 and this is 12, 13. So option B. Good problem. It is, we cannot apply directly the undecayed property here. Why? Because these minterms are different. Boolean variables are different. Yeah, I think ये प्रॉब्लम हमने किया होगा, I think so शायद. So आप लोग स्मरण होगा आंसर C. Next, the switching circuit given in the figure can be expressed in binary logic notations as. Tell me how we can express this thing as binary logic notations. Here these two are parallel, so means what I can say now, this is A plus B. These two is what, tell me now here, C plus D. And this is E, so that is L is given as what, tell me, A plus B into C plus D into what, tell me now, E. So what's the option, tell me? A. Fine. Okay. So yeah, that's for the today's sessions. So we have finished up to 80 problems. We have finished it now. Now let's do the remaining problems in the next session. Okay, then all of you do follow the sessions and regularly. And so the students who can plan for Unacademy subscription, they can take this Unacademy subscription by using the code of BVREDDY, and use the code of BVREDDY to get this great opportunities. Okay. Use the code of BVREDDY and you can avail the great features of Unacademy and the best learning platform with the top educators. So let's meet in the course and use the code of BVREDDY. Next class we'll see the remaining problems.